Hello again, everybody. Do you want a secret ninja trick for percent increase and decrease problems? If so, stay tuned. Hey there, it's Mark Nolde. I've been teaching high school math for almost 25 years. I show students techniques for tough problems that we all struggle with. Typical example of what I might see a pre-algebra student struggle with. This one says John paid $1.68 in 6% sales tax for a board game. What was the original price of the board game? So, an algebra student would quickly divide 1.68 by 0.06, but if you're just learning this, the best tool that you have is the ratio box. So a ratio box looks like this. It has two columns. One column is we label ratio, and the other one we label actual. So actual. So this is a percent increase problem. So these frequently come with a before. We want to know the before price of the board game, the increase, which is this 6% sales tax, and the after price, although it's not asking for an after price here. So what we could do is say, well, the generic term would be to say before. So the original price is always 100%, right? And we frequently don't write the percent. You can write 100. In fact, many times people write 1.00. But for students, it's easier in the beginning to just write the percent. So before, and then there's an increase. There's either an increase or a decrease. But in this case, there's an increase because it's sales tax, 6% sales tax. So add 6%. And that gives us an after price. So the after price, if I add these two numbers up, is 106. So I want to know what is the original price, the before price here. So, and the sales tax I know is 1.68. So what I could do is, it's called a ratio box because we set up two equal ratios. So I could make this into a ratio problem where I cross multiply. Take your known product, 100 times 1.68, and divide by the known factor 6. So it looks like this. The before is going to be 100 times 1.68 divided by 6. And if you get your handy dandy calculator out, it will, you'd have 1.68 times 100, which is 168, divided by 6. And 168 divided by 6 should give us, I'm looking for my calculator, and there it is, 168 divided by 6. So 28. So notice the before up here is $28, and this is what the question was asking for. So the correct answer would be it was $28. But a question could also ask, how much total did John pay for this board game? So what we would do there is just add 28 to $1.68, and we'd say, well, he paid $29.68. Make this look less like a Z and more like a 2. How about a little bit of an erase here? Use the erasure principle. So 2. So $29.68 was the total. 168 was the amount of the tax that was given in the problem, and the before must have been a $28 game. So there's one quick example. Now let me show you the second example where they ask for the after. So Sonia had a delightful meal at a local restaurant that cost $78.90. So that's a before number. The service was very good, so she wanted to leave an 18% tip. How much tip did she leave, and what was the total cost of the meal? All right, so this is a job for a ratio box. An advanced algebra student might just multiply 0.18 times 78.90 or times 1.18 to get the total. but let's walk through this and show you how to get the correct answer. So we're looking at a ratio box. So we call it a ratio box because we write the word ratio right in there. So ratio box, and we have actual numbers. So in this case, again, the ratios are the percents. So the before is the actual meal. I'll write meal in parentheses here. So the before was $78.90, the actual. The actual ratio amount would be 100%. And then we're going to have an increase because she's leaving a tip. That's more money. And I'll put tip here in parentheses. So the tip that she wanted to leave was 18%. So we want to know how much was this tip and how much was the total. So the after is our total. So after, maybe I'll write total in there, parentheses. So when I add 118, I get 118. So that's information that I can figure out just from the problem. Now, if I want to figure out what the amount of the tip was, I can just cross multiply these. So I could say, for the amount of the tip, let's do red. We'll say 100 is to 118 as 78.90 is to what number? Well, I'm actually looking at the, erase that whole thing. I should have written 18 there. 18 is to the tip. So I'll write, this is the amount of the tip. So what we do is we cross multiply. We take the known product, these are the two numbers that are diagonal from one another, and divide by the known factor. So when I do that on my calculator, I find out that the tip was, let's see, $14.20. So now I could go in here and say, well, this number's figured out now. I could do 1428, or 1420, sorry. And then two things I could do here. I could cross multiply 100 with the after number and 118 with this. Or maybe an easier way to do it is just to add these two numbers together. So when I add these two numbers together, keep pausing my video, it looks like I get, let me erase my question mark, and when I add those together, it's $93.10. So that answers the total cost of the meal question, and the tip part, the 18% tip, I'll color match it, was in red. So that's the second example. So I'll show you one more quick example when we actually have a decrease instead of an increase. So Paul had a 20% discount when he paid $48 for a new video game. What was the original price of the video game? How much was his discount? So this is another job for a ratio box, right? So write down a ratio in one column and an actual heading for another column. And what was the original price? That's what it was before the discount. So this is always 100%. And what we're looking for is what was the actual price. Because, let's see, this is a decrease. He had a discount. So it was decreased the price by 20%. So the after price, right, for the price on sale, the sale price, would be 80%. So we're just taking 100% minus 20% and coming up with 80%. So we also know that he paid $48 for the new game. So that goes here. So we have two things that we need to figure out. The first thing to figure out is what was the original price of the game. So let me color code with my school colors. So this is going to be the red, and then I'll do blue. We want to know how much was the discount and what was the original price of the game. So the original price of the game, let's see. I would cross multiply these numbers and say, well, 100 over 80 equals, make an 80, equals what number over 48? So cross multiply. This is the known product. This is the known factor. So we would type into our calculator, what's 100 times 48? And then we would divide that product by 80. And if we do our math correctly, we should come up with an original price of $60. All right, good job. So let's look at the next one. I'll switch to blue for that one and erase some of my things here. Erase. And that was $60. So notice, again, there's two different things that I could do to figure out this number right here that I'm pointing at. So I could say 60 minus what equals 48, and we could say, well, that's some simple math. That's just 60 minus 12. Or I could have cross multiplied. So different people will do it different ways. So 20% is to, I could either do this is to 80 or is to 100, but I already dotted it out as an 80, equals what number over 48? So to do this, just multiply these two numbers and divide by the third number, the known factor. So I could say this question mark equals 20 times 48, and then divide that product by 80. Another one that would get you the exact same answer would have been to say 100 is to 20 as 60 is to what number? So if I cross multiplied 20 times 60, I'd get 1200, and divide by 100, I'd get still the same answer, 12. All right, so hopefully those two questions helped you out. But again, this is called a ratio box. We actually write the word ratio and another column that we label actual. And here's where we put the percents in these tax problems or tip problems. And this is where we write the actual amounts. All right, question of the day. What is the hardest pre-algebra problem for you? Let me know in the comments down below. I hope you liked ratio boxes. And don't forget, like the video and subscribe if you got some value. And as always, don't forget, math is not a spectator sport. The only way to learn math is to do math.